Today we're going to talk about cellular respiration and photosynthesis. We're going to be comparing them. While we are comparing them, what we're actually going to find is that they are a cycle and are actually dependent on one another. So I want you to follow along in your notes as we move through this PowerPoint. Okay, so what does the chemical formula tell us? So we have 10 H2O molecules here. That indicates there are 10 molecules of water. So, again, follow along in your notes. There are 10 molecules of water. So, how many total atoms are present in 10 H2O? So, we have 10 hydrogen molecules, but there are 2 of each hydrogen molecules. So, 10 times 2, we have 20 hydrogen atoms. Then we look at oxygen. So when there is no subscript, that is just indicating there is only one atom. So 10 times 1, there are 10 oxygen atoms. All right, so what does a chemical equation tell us? So your arrow here represents that a reaction has occurred or is occurring. It reads as yields or produces. I prefer to say produces. On the left side of the chemical equation, these are called your reactants. They are what go into the chemical reaction to react. And they produce or yield products. Your products are what you see on the right side of the chemical equation. So if we look at this, we have 6 CO2 and 6 H2O. And these yield or produce 6 O2, and this I'm just going to call glucose because that's what it is. So let's look at the number of atoms there are in each part of this equation. Okay, 6 CO2. So we've got 6 carbon molecules, and if you times 6 times 2, we have 12 oxygen molecules. Over here, 6 times 2, we have 12 hydrogen molecules, and 6 times 1, 6 oxygen molecules. So again, make sure you're staying along in your notes. All right, so on the product side, we have 6 times 2, 12 oxygen. And over here we have 6 carbon, 12 hydrogen, and 6 oxygen. So on your reactant side, so the substances that go into the chemical reaction, how many total atoms do we have? Okay, so we have 6 carbon molecules. We have 12 plus 6. So 18 oxygen and 12 hydrogen. 12 hydrogen, 18 oxygen. So once a reaction has occurred on the product side, we have 12 plus 6. So 18 oxygen, 12 hydrogen, 6 carbon, 6 carbon, 12 hydrogen, 18 oxygen. So conservation of mass, even though a reaction has occurred, you still have the same number of atoms in your products as you did in the reactants. They're just moved around to create a new substance. All right, so let's just break down a chemical formula real quick. So we're going to answer what the coefficient is, which is the number in front of the chemical formula. And we're going to answer what the subscript is, which is the number that is kind of below the specific atom. So our subscript, so you're going to go ahead and write this down. This, if you're not already there, starts on the back of the first page. So this is the number of atoms of the element right before it. So in this case, there are 2 hydrogens. Now the coefficient, or the number in front of your molecules, tells you the number of compounds or molecules. I prefer to say molecules. So here we have 10 molecules of H2O. So under coefficient, write that it is the number of molecules. Okay, so let's look at getting into comparing cellular respiration and photosynthesis. So we went over reactants and products, as well as how to read chemical formulas, because it is necessary for you to understand the chemical formulas involved in chemical or cell respiration and photosynthesis. All right, so let's see what we already know. What is the relationship between the apple tree and the person? Okay, so let's start with when you exhale, what do you breathe out? So that is carbon dioxide. Okay, just kidding. It wants to go another way. So trees give off oxygen. So that's really nice for us because if you look at this arrow, we breathe in oxygen. So while we do breathe in oxygen, again, we breathe out carbon dioxide. So on your little diagram below, I want you to write down in these spots where they occur in the cycle. Okay, finally, you have glucose. So glucose is made during photosynthesis by plants. So while glucose needs to be written up there at the top, so glucose is a product of photosynthesis as well as oxygen. So glucose can be used by the plant itself for growth, or when we eat plants, we can also use that glucose in our digestive systems. So just to be clear, CO2 is the formula for carbon dioxide gas, and O2 is oxygen gas. So you need to be familiar. You may see carbon dioxide, you may see CO2, you may see O2, or you may see oxygen gas. But you need to make sure you understand what the chemical formula is telling you. All right, so photosynthesis and cellular respiration. And so make sure you flip to your third page here. These link organisms together in their environment. So at the beginning of all food chains, we find producers. So think back to our ecology unit. So examples are going to be plants, and these perform photosynthesis. So producers are also called autotrophs. Auto meaning self, so they make their own food. So they get their food technically from the sunlight. So if you follow this arrow over here to our hippo, Many organisms are consumers. So if you think back to your ecology unit, we have different levels of consumers. But in any case, they must eat food to obtain their energy. So consumers are also called heterotrophs because they obtain their energy through different sources. So let's give some other examples of autotrophs. So autotrophs are plants. Oop. So just brainstorm for a second. So think about plants that you eat. So let's say carrots, lettuce. We don't really eat this, but a lot of animals do. Grass. And other examples of heterotrophs include anywhere from frogs to rabbits to foxes to apex predators such as polar bears. Okay, so let's go to the bottom of this page. Both photosynthesis and cellular respiration are processes. So we're going to use these words to help us define each process. Okay, so within these processes, you have transformation. So blank transforms into blank. So as I'm going along, write in the appropriate terms. So on the left side, we have our start. This is the start. These are your inputs, INPUTS. And they're also your reactants. Ultimately, these are all ways of saying anything that goes into the reaction. So everything on the left, your reactant side. So in the process of photosynthesis or cell respiration, these are transformed into finished products, outputs or output, or as I would prefer you to refer to them as products. All right, so I want you to flip over to your next page. Okay, so we're going to compare cellular respiration and photosynthesis on a little bit higher level. So, photosynthesis and cell respiration are life's most important processes. The reason is that energy must flow through life to animate it. So, without these two processes in this cyclical manner, we would have no life. So, take a look at this diagram here. You've got to understand that both of these products, again, move in a cycle. So we're going to use the diagram to answer the following questions. So let's analyze. So above in the diagram, question number 1. So what are the reactants in photosynthesis? So here's photosynthesis. Here are our reactants. So the reactants for photosynthesis are going to be your 6CO2 or your 6 carbon dioxide molecules. So make sure you're writing that down underneath number 1. You're also going to have, so I use a plus sign instead of the little boxes. So you also have 6 H2O molecules, so 6 molecules of water. So plus 6H2O. And additionally, you have solar energy. Solar energy. So these are the reactants. Now, let's look at what photosynthesis yields, or what are the products of photosynthesis. Okay, so from photosynthesis, we get glucose. So I want you to write both glucose and the chemical formula for it. So it is C6H12O2, so that's glucose, plus 6O2 molecules. So O2, that's oxygen. So photosynthesis takes carbon dioxide, water, and solar energy and produces glucose and oxygen. All right, so now let's look at our reactants for cellular respiration. So we're moving to the next side. So what goes into this reaction? So your reactants here are glucose and oxygen. Again, I want you to write out the chemical formula for glucose so that you can get comfortable with it. So you're going to go right under number 3, write down C6H12O6. Now under that, you can label it glucose. Plus sign, and then 6O2. So 6 oxygen molecules. All right, so what I want to point out to you here is that the products of photosynthesis, glucose and oxygen, are the reactants for cellular respiration and vice versa. So the cyclical nature can help you more easily memorize, the products and reactants for these two processes, because the products of one are the reactants for the other and vice versa, with exception to the energy produced. Okay, with that said, let's move on. So what are our products? What is what does cellular respiration yield? Okay, so our products here are, unsurprisingly, the reactants for photosynthesis. So we have 6 CO2, or 6 carbon dioxide molecules, and 6 H2O, or 6 water molecules. And so, like I said earlier, the only exception is going to be the energy. Cellular respiration produces energy for the cell, so it produces 36 ATP. So that's our ATP. It's the easiest, 1, 2, 3. So we get from cellular respiration ATP to use as energy in cells. So the cyclical nature of these two processes allows all of that to come from solar energy. Okay, so how is energy transferred within the cycle? So everything needs a constant supply of energy, specifically solar energy. So we start with our solar energy, so that's already filled out for you. So notice these arrows at the top. So this first arrow between the yellow and green represent photosynthesis. So solar energy that goes through photosynthesis. So go ahead and label that there. You can either label it sideways how it is, or you can label it above the arrow. PHOTOSYNTHESIS. SIS. So after photosynthesis, we get the product of glucose. So write glucose into your box there. Okay, so with glucose, it is going to go through respiration, specifically cell respiration. So go ahead and write that either the way it is on the screen or right above that arrow. So write in respiration. So glucose is the reactant after going through cellular respiration. It produces ATP energy. So that ATP energy is energy for the cell. So go ahead and write that in. Okay, so finally, we can see that the cellular processes and heat. So while this is a very good system, there's always going to be some energy loss, just like we saw in our food pyramid and ecology. There's always some energy loss to cellular processes and heat. So in that last box, make sure you get that down. CELLULAR PROCESSES and heat, HEAT. So that is the energy flow that we're looking at here in what seems like a pretty complicated cycle, but it is not once we break it down. Okay, so if you missed this earlier, you can go back a page and we can double check. So this is your little diagram that you filled out. So remember, the cycle needs a constant input of solar energy. Photosynthesis will transform solar energy into glucose that is broken down in cellular respiration and produces 36 ATP. So in summary, the molecules or elements must be recycled so that energy can flow. So again, you can double check this. Together, photosynthesis and cellular respiration form a cycle because these products are the products of one are the reactants of the other, and vice versa. All right, so let's just take a look here at photosynthesis. So photosynthesis transforms solar energy to produce glucose and oxygen. This occurs within organelles called chloroplasts. So chloroplasts are organelles that are only found in plants. So we're going to use the diagram to write the chemical equation for photosynthesis. So you have 6 CO2 or 6 carbon dioxide molecules plus 6 H2O, 6 water molecules, and light energy. And you have your little arrow here, meaning yields or produces. So photosynthesis produces the products of glucose, which, if you want to write the chemical equation or the molecule down, is C6H12O2 and 6O2 or 6 oxygens. Again, remember your reactants are your starting materials and your products are the materials created after the process. All right, so let's scoot down just a little bit. Let's look at our cellular respiration. So cell respiration transforms chemical energy found in the bonds of glucose into a more usable form called ATP. So ATP, that is the energy form that the cell uses. So this occurs in the organelle, the mitochondria. So remember, your mitochondria is the powerhouse of the cell. So that name comes from its ability to make ATP energy. So let's write down our chemical equation for cell respiration. So you're going to take glucose, so write that in, Glucose. Under that, go ahead and write down the molecule, so that's C6H12O6. So plus 6O2, six oxygen molecules. So these are the reactants, the starting materials, and they produce 6 CO2 or 6 carbon dioxide molecules, 6 H2O or 6 water molecules, in addition to 36 ATP. So this process yields cellular energy from glucose. So again, your reactants are on the left, your products are on the right. Okay, so let's do some reviewing. Cellular respiration and photosynthesis comparison chart. Okay, so on the left you have photosynthesis, on the right you have cellular respiration. So, happens in autotrophs or heterotrophs. Remember that autotrophs are your plants and heterotrophs are your animals. Okay, photosynthesis only occurs in autotrophs. But cellular respiration actually occurs in both. So cell respiration occurs in autotrophs and heterotrophs. Okay, so let's go down to our next level. So happens in the mitochondria or chloroplast. So photosynthesis occurs in the chloroplast. So the chloroplast is only in plant cells. So cellular respiration, where we create ATP, occurs in the mitochondria. Mitochondria. Right, so our purpose and function here. So basically, it transforms what into what? So photosynthesis transforms energy from light into glucose. So if you want to quickly, like if you want to paraphrase this, you could put transforms light energy into glucose. All right, so what is our purpose or function of cell respiration? So it transforms energy from glucose into ATP. So to paraphrase this, you can simply write transforms glucose into ATP energy. So transforms glucose into ATP energy. Okay, so what are your reactants in photosynthesis? So the things that go into the reaction. So your reactants are going to be light, carbon dioxide, which you can just use the short form, the molecule, CO2, and water, or H2O. Okay, so what are the reactants that go into cellular respiration. Oh, just kidding. We're going to look at the products of photosynthesis first. So the products of photosynthesis, or the end result, is glucose, or C6H12O2, and oxygen, or just O2. So if we look at cell respiration, remember the reactants of one are the products of the other and vice versa, except for energy. So your reactants for cell respiration are, what do you know? The products of photosynthesis. So glucose and oxygen. So what do you think your products for cell respiration are going to be? So other than the energy, so we'll start with that, 36 ATP. So after the energy, the products are the same as the reactants of photosynthesis. You have carbon dioxide, or CO2, and water, or H2O. Okay, so for this next part, the directions indicate for you to note the following statements as true of photosynthesis, or true of cellular respiration, or true of both. So you are going to go back through the notes that we have just been through, and this is your exit ticket for today. So you